Product rule of differentiation. So, unlike the chain rule, this time if you have a function that is two functions that you think you can differentiate multiplied by each other. If you have that, you've got to think about it. They are affecting each other, so the derivatives of each function multiply to the other function. Think about it. They affect each other, they change each other. Okay, this is a rate of change. U's rate of change happens to V. V's rate of change happens to U. Okay? Why don't the rate of change happen to each other? Because that would be infinitesimal. It would be 0, wouldn't it? It'd be like multiplying 0 by 0. So that's the rule, but let's have a look at it in an example. So let's have a look at two functions multiplied together that we think we could definitely differentiate separately. Okay, pretty sure we could differentiate these separately. Let's call them U and V. And let's put this at the side. This helps for later when we do the quotient rule. Now let's multiply the inside rainbow and multiply the outside rainbow. U dash V plus U V dash. So let's fill in this side. We'll call that U. That's the derivative of it. This is V. There's the derivative of it. So when we do Y dash, you'll remember that it is U dash V plus U V dash. U dash V plus U V dash. May as well put the V dash first just for neatness. Now, do you have to do anything? Well, if you need the gradient for a tangent or something, no. But if you need to work with it later on, especially later on in other topics, yes you do. So we can expand it and collect like terms. Looks like we've got some squares over here, a squared over there, maybe some x terms, and a number. Okay, it's going to be a quadratic. So first we'll expand it. There we go. And look at some like terms there. And that's it. So Y dash is 9x squared plus 6x plus 3, or you could factor off it both, so it isn't going to change too much. So let's do one more. Now what is this combining? It's combining two rules we've done. How about we make this 3x to the 4 times 2x minus 1 to the power of 4. Now, yeah, we'll call this U. And yeah, we'll call this V. But what do we got to do with V? That's right, got to do the chain rule. So, first of all, U, 3x to the 4, U dash. Drop it, 4 times 3 is 12. Take 1 off it, x cubed. V, 2x minus 1 to the 4, V dash. Alright, you drop the 4, take 1 off the 4 to make it a 3. And you've also got a times 2, y times 2, because that's the derivative of the bracket. Can't just do chain rule just like the index rule. You've got to complete the chain. So the 4 times 2 will give you 8. Well, you can do this in 2 lines, of course. 2x minus 1 to 3. So U dash V plus U V dash. Something else very important we have to do to this. When we get to it, I'll show you. 12x cubed, that's out of 2x minus 1 to the 4 plus 8 times 3, 24x to the 4, 2x minus 1 to the 3. Very, very important that we look at this. Common, yeah, there's something very common to those two. Common here, yeah, there's something very common to these two. First of all, what's common to 12x cubed and 24x to the 4? 12x cubed. What's common to 2x minus 1 to the 4 and 2x minus 1 to the 3? 2x minus 1 to the 3. What's left? Let's have a look. You know what? My computer, I'll get this out of the way. Go on. Now, what's left here? Well, the 12x minus 3, they all got used up. Have a look here. One of the 2x minus 1s didn't get used, so we'll put that in here. Now, the next bit. We're looking here now. Yeah. What's left here? Well, there's a 2 and an x from the 24x to the 4. Plus 2x. Can we see anything else? No. All the 2x minus 1 to the cube got used up. So, what we've done there is factorise it. Why? Hey, now it's all in factors. Very powerful for later on. 4x minus 1. Cool.